Hi folks, we're going to take a look at number 10 from page 206. So they give us this cubic polynomial and they want us to determine the missing coefficients A, B, and C. Okay, and the information they give us is that there's a local extremum at 211 and there's a point of inflection at 1,5. Okay, so since we have three unknowns, we should expect three pieces of information, but it looks like we're actually given more because the fact that we have a local extremum at this point and a point of inflection at that point means these 2 points are on the function, and each of these scenarios gives us another piece of information. A local extremum at 211 tells us that f prime at 2 needs to be equal to 0. Now I know it's got to be equal to 0, and as opposed to the possibility where it doesn't exist, because we're dealing with a polynomial, derivative exists everywhere. Same thing with the second derivative. So knowing that we have a point of inflection here, okay, point of inflection tells us that f double prime at 1 has to also be equal to 0. Okay, so it looks like we have even more than we need. Now in terms of what I start with, I'd like to start as much as possible with things that involve 0. Okay, and in particular, I know that when I take the derivative of a polynomial, this constant term is going to disappear. So it means what I'm left with is an easier expression. Okay, and then, taking the second derivative makes it even easier. So I'm actually going to start with this information as opposed to the fact that these points are on the line. Okay, so let's start by finding the derivatives. So f prime at x is just going to be a times 3x squared, so 3ax squared, plus b times 2x, so 2bx, and of course the derivative of c, just a constant, is equal to 0. Okay, and then from here I can find the second derivative. Okay, so here I have 3a times derivative of x squared is 2x, so 6ax, plus derivative of x is just 1, so I'm just left with the constant 2b. Okay, so let's start by creating one equation in a and b by using the fact that f prime at 2 has to be equal to 0. So f prime at 2, we'll replace x by 2, so 4 times 3 is 12. So we have 12a plus 2 times 3 is 6, so 6b is equal to 0. Oops, 6b. Okay, in fact, we can simplify this equation. Let's, sorry, I just realized I think I made a mistake here. Here we've got 2 times 2 is 4, not 6. So this should be 4b. Sorry about that. Okay, just to repeat here, I'm replacing 2 into the derivative. So 2 squared is 4 times 3 is 12. And then here, x is 2, so 2 times 2 is 4. Okay, and here we can simplify this a little more. So divide both sides by 4. So 3a plus b equals 0. So there's one equation, okay, in a and b. And now the second derivative hopefully will help me find a second equation. So f prime at 1, f double prime at 1 is also equal to 0. So let's stick x equals 1 here. So 6 times 1 is 6, so we have 6a plus, and here there's no x, so just 2b is equal to 0. And again, we can simplify this, divide both sides by 2, so we get 3a plus b is equal to 0. So there's our second equation. Okay, and so notice what we have here, something very interesting. These equations are exactly the same. Okay, so it means, if you think of this as a system of linear equations, these two lines are exactly the same. So there's infinitely many points of intersection. So working with these two pieces of information did not allow us to solve for a and b, as I would have hoped. So this is a pretty nice question, because it's thrown us for a loop here. Okay, but it does tell us a relationship between a and b. Okay, so what we can say is that b has to be equal to negative 3a. Okay, now of course there's infinitely many pairs that have this relationship, but at least we now can write b in terms of a. Okay, so a bit of a more interesting problem than we've dealt with before. Okay, so now though I still have two other pieces of information that I can work with. I know that so here f at 2 is equal to 11. Okay, so let's stick 2 into the equation. So we have 2 cubed is 8a. So 8a, and 2 squared is 4, so plus 4b. Okay, but plus c, and we know that's equal to 11. And then we also have f at 1 is equal to 5. So let's stick x equals 1 here. So we just have a plus, stick in 1, b plus c is equal to 5. Okay, but remember, we know that b is equal to negative 3a. So we can now replace, wherever we see b, replace it by negative 3a. So we have 8a. Okay, so this is plus 4 times negative 3a plus c equals 11. And here a plus negative 3a plus c is equal to 5. And now what we're going to have instead is two equations in terms of a and c. And I really hope they're not the same equation this time, because then we got a problem. Okay, so here we have 8 minus 12. So negative 4a plus c is equal to 11. And here we have 1 minus 3, so negative 2a plus c is equal to 5. And these are going to be our two equations that we can solve. So we'll call this equation 1, call this equation 2. So negative 2a plus c is equal to 5. And I'm going to subtract them to eliminate the c. Okay. So here we have negative 4 plus 2, so negative 2a. The c's cancel out, so 11 minus 5 is 6. So we've got a is equal to negative 3. So there's one of our solutions. Okay, but we know that b is equal to negative 3a. That's what we got from working with the derivative and second derivative. So negative 3 times negative 3. So we've got b is equal to 9. There's our second coefficient. And now I can use one of these equations here to solve for c. So I'll use equation 2. So here we have negative 2a, but a is equal to negative 3. Okay, plus c is equal to 5. So we have 6 plus c is equal to 5. So c is equal to 5 minus 6, negative 1. Okay, so there you have it. There's our three coefficients that we were missing. So just to recap here, okay, we've seen this type of problem before now where we're looking for missing coefficients in the function, and we use information about the function itself, and in this case here the first and second derivative, and we just apply that information to eventually solve for those unknowns. Okay, this one here had a bit of a trick to it in that two of those pieces of information led us to only one relationship. Okay, so with the first and second derivative being 0 at those points, we weren't able to solve for both a and b, but we were able to determine a relationship between the unknowns.